All right, so this is 6.1. We're going to be working out the two homework questions. I try to teach, what I think I'm going to do with these videos is try to teach the material and then come back through and work through the homework problems with you. I really encourage you to watch both videos. That way that you get all of the little details of the definitions and what's actually going on, why these formulas work the way they do, and questions that will pop up, little nuggets I give you throughout that pop up on the test. So just make sure you watch both videos. But if you're stuck on your homework, you're not really sure what to do, these are going to help you more with the homework problems. Okay, so hopefully it's helpful. If not, shoot me an email, give me some feedback, and then, I can just make them all as one video if that's better. Okay, so random sample, 35 students. Sample mean, X bar equal to 25. From past studies, it is known that the population standard deviation, sigma, is 1.8, but the population distribution is unknown. All right, AC wants to estimate the mean age of all students currently enrolled with a 95% confidence interval for the mean. So look, guys, if we knew what the true mean was, mu, we wouldn't need to do anything else. We'd have it right there and we'd be done. But we don't know what it is, and we're trying to estimate it with 95% confidence. Now, before we jump into this problem, excuse me, before we get into this problem, that means we got to think about one thing, all right? Do we have the keys to our Ferrari? What's our Ferrari? The central limit theorem, CLT, not the BLT, right? So, do we have the keys? Do we know sigma? All right, we look through the problem. Standard deviation. If I see population standard deviation, that is sigma. Key word, population standard deviation. Look for population standard deviation. So sigma is known. Now, is a random sample good? What else? First number, 35. What is that? 35 is n. Now, n is greater than or equal to 30. Boom. That's what we needed. We needed to know that n was greater than or equal to 30. CLT. That's what I'll be looking for on your test. Okay? CLT. Random sample, n greater than or equal to 30. I don't care that I don't know what the population, how it's distributed, because I don't have to know it's normally distributed if n is greater than or equal to 30. I've got the keys to my Ferrari. Let's not sit around in the parking lot. Okay, to drive this Ferrari, I need to know the pit players. So n is equal to 35. N is 35. What's the next number I see? 25, X bar. The sample mean is 25. Okay. Standard deviation, population standard deviation, 1.8. What else do we need? Okay, I see the next number I've got is 95%. What is this talking about? This is my C. C is 0.95. Okay, 95% sure. All right. So what's the formula say to do? X bar minus ZC sigma over square root of n less than mu less than X bar plus ZC sigma over square root of n. Okay, we've got X bar, so that's 25. ZC, I don't know what that is yet, but sigma is 1.8, square root of n, square root 35. So really, it looks like ZC is the only thing that I need to figure it out. If I figure that out, I got it. Okay, so write down everything that you know. All these word problems are the same. Look for the numbers, figure out what they want. They want a confidence interval. That's why I'm using this confidence interval right here, people. Right there for you. Okay, maybe that's a little bit better. Look at that. Okay. ZC, how am I going to calculate it? Well, you got two options. Either use the formula I gave you or draw the picture. You guys know I'm a picture guy. If 95% is in the middle, 95% in the middle, and there's 100% total, what's on the edges? Well, there's only 5% left. Do I put all 5% on the left side? No. Put half of it over here, 2.5%, and half of it over here, 2.5%. Okay? So, go look it up in the chart. 0.0250. 0.0250. When I go look it up, negative ZC. Give you a second to look that up while I try to find it. All right. 1.96 negative over here. Now what's in the middle? 0. So on this side, ZC, positive ZC is 1.96. So what goes in my parentheses over here? 1.96, and over here 1.96. One is a plus and the other is a minus. I'm telling you, the easiest way to do this problem is to calculate the error individually by itself. And then plus and minus it from the answer that you get. Okay? So if you type this into your calculator, you should get 24.4036, less than the mean, less than, and then on this side, you're going to get 25.5963. All right. Now, to interpret this, how do we interpret this? Let me move this over here. How do I interpret my answer? Very important. With 95% confidence, the structure here, the mean age of all the students is between 24.4 and 25.6 years. Okay? So that's how I want you to write your answer. With, and then whatever your confidence level, and then the mean of whatever you're talking about. Here we were talking about age of students is between, and then your lower number and your upper number. Always in that format there. Okay? Last word problem right here. Second 10-point question. All right, 6.1. Determine the minimum sample size needed when you want to be 99% confident that the sample mean is within 1.5 units of the population mean and population standard deviation sigma 6.2. Assume the population is normally distributed. Now, anytime you see determine the minimum sample size needed, okay, you got to ask yourself, what do they want? They want to know what n is. So we're going to use the formula that involves n. Go figure. I get all sorts of creative stuff on this problem. Don't get creative. Just use your noggin. All right? I want to be 99% confident. That tells me my ZC is a 99% ZC. Okay? So 99% ZC means what? 99% in the middle, and that means 0.5% over here and 0.5% over here. Now be careful. If we're on this side and 0.5%, that's 0.0050. It's not 0.05, it's 0050. Go look that number up in the chart. You're going to get a Z equal to, and on this negative side, on the zero negative side, it's going to be negative 2.575 when you go look that number up in the chart. Now, what I'm going to tell you is that whether you put negative or positive, it's not going to matter. Why? Because I'm squaring this product in quotient. So square a negative, it becomes positive. Square a positive, it becomes positive, stays positive. So I have, we'll just type in 2.575 because who cares about it being plus or minus, all right? Technically ZC, if negative ZC is this and positive ZC is the positive one. Okay, times sigma. What is sigma? Well, look, guys, we used one of the numbers. I got two more numbers. Let's not overthink this. Here's a number and here's a number. I know for a fact that these two numbers match. Okay, so that is sigma. That's 6.2. Put it there. Guess what? There was one number you didn't use. What number was that? That was the E. 1.5. So guess where it's going to go? Right here. Type it in your calculator, square it, get something like 113.28. Am I going to go out and ask somebody, 0.28 people the question? I don't think so. You don't go out and ask somebody's leg, do you like ice cream? They're going to be like, no, we don't like ice cream. We got to carry this stuff, right? So, the minimum sample size needed is what? N equal to 113? No, always round up. 114. Don't let that trick you. All right, guys, this concludes 6.1, the two problems I was going to work through. Thank you.